Hey everybody, okay, so now we're going to graph linear inequalities. All right, so let's just talk real quick about what an inequality looks like. An inequality, a linear inequality, has at least an x or a y, could have both, and it has an inequality symbol, okay? So at least an x or a y, and it has an inequality symbol. All right, and A and B, they're just talking about A and B being numbers, and both of them are not zero. One of them can be, but they aren't both zero. All right, so a solution of a linear inequality is what makes the statement true when you substitute those values in, and I'm about to show you what this means. All right, so we want to determine whether each ordered pair is a solution to this inequality. Now, let me just preface this with, it is possible that all of them could be solutions. So you shouldn't stop once you find a solution and say, oh, I found it. It is possible because there are an infinite number of solutions to this problem, okay? So you have to test each and every one, all right? So we're going to put, in this case, 0 in for x and 0 in for y, and we're going to test it and see if it makes a true statement. So on part A, we would have 0 is greater than 0 plus 4. 0 is greater than 4. That is not true. So we would say no. So your answers, your appropriate answers to this would be no or yes or no, okay? So we're going to test out the next one. So on part B, we're going to put in 1 for x and 6 for y, and we're going to see if that makes a true statement. So I've got 6 is greater than 1 plus 4. 6 is greater than 5. That is a true statement. So we would say yes for this one, okay? Now on this next one, we're going to put in 2 for x and 6 for y and see if that makes a true statement. So I've got 6 is equal to, oops, that's not correct. We're doing inequalities here. There we go. Okay, so 6 is greater than 2 plus 4. 6 is greater than 6. No, that's false. Now, if it had had the equal to symbol underneath, then that would be true because that's greater than or equal to. But in this case, it doesn't have that. So we have to say that this is false because 6 is not greater than 6. 6 is actually equal to 6. So I would say no here. Okay, on part D, we're going to put in negative 5 for x and negative 15 for y. So negative 15 is greater than negative 5 plus 4. So negative 15 is greater than negative 1. That's also false. Okay, negative 15 is less than. Think about negative numbers as money that you owe somebody. Okay, so which one is greater? And don't forget too, whenever we're looking at a number line, so here's negative 1, and down here somewhere is negative 15, okay? So the number that is further on the right is your bigger number, okay? And in this case, this makes a false statement, okay? So I would say no here. All right, the last one, part E, I'm going to put in negative 8 for x and 12 for y and see if that makes a true statement. So 12 is greater than negative 8 plus 4. 12 is greater than negative 4. That is a true statement. So I would say yes on this last one. All right, so some textbooks use parentheses or brackets to determine whether or not a number is included, okay? So in this case, I'm going to blow this up just a little bit. So the parenthesis means everything just to the left of A, but don't include A in this case. And A can be any number. If it makes you feel better, let's call it 10 in this case, okay? So x is less than 10. That means that x can be 9.99999999999, but it can't be 10, okay? And it can also be any number that's less than 10. Now in this case over here, the bracket means we actually include the number. So let's go back with our 10 number, and let's just say that x can be 10. In this case, it is allowed to be 10, and any number that is less than 10. Okay, and I know that in some classes you guys saw that they didn't use parentheses and brackets. They used open circles or closed circles, so it looked like this. X is less than 10. They used a graph that looked like this, and it was, in this case, it was an open circle, and it went to the left, right? Remember the open circle and the closed circles? And so for this one over here, it would be a closed circle or a filled in circle, however you want to say that. All right, so the bracket and the closed or filled in circle is the same thing, and the parenthesis and the open circle is the same thing. It just depends on what textbook you're looking at. All right, so this graph right here just shows this equation, all right? So y is equal to 2x plus 1. That's what this line is right here, okay? Now, we've never shaded a region in this class before, but now we're shading regions. And anytime you shade a region, it's no longer an equal sign. Now it is actually going to be greater than or less than if it's shaded. That's only when things are shaded, okay? So now, here's the line, y equals 2x minus 1. Notice that it is a solid line, not a dashed line. When it's a dashed line, that means we don't include the solutions that lie on that line. This is a solid line, so I know that it will be greater than or equal to. And how do I know that it's greater than? Well, okay, here's what I want you to think about. So let's just put a dot right here on this y-axis. Is the region shaded above or below? If it is shaded above, then you will have greater than. If it is shaded below, you will have less than, okay? And because this is a solid line, that's why we have the equal to symbol underneath. Sorry about my alarm. All right, so we have written an inequality that goes with this graph. All right, for this problem, they tell us that the boundary line shown is 2x plus 3y equals 6. Well, that's written in standard form. It's hard to really tell what your slope is and what your y-intercept is when things are written in standard form. It's okay. We can leave it in standard form. The same rules still apply, except this time we have a dotted line, which means that we do not have the equal to symbol underneath the inequality symbol. So I can leave it as 2x plus 3y, and I've got, oops, that'll be 6 over here. Okay, now I just need to decide which inequality. Do I want less than or do I want greater than? Well, think about this. Where is the region shaded if I put a dot right here on the y-intercept? Is it shaded above that dot or below that dot? Where the numbers are bigger or where the numbers are smaller? Okay, if you say smaller, and you should in this case because the shaded region is below, then we would have a less than symbol here. Okay? I hope that makes sense. Also, if you wanted to turn this into slope-intercept form, you could. And then divide everything by 3. So it doesn't really matter if it's written in standard form. This one is standard form. And this one is slope-intercept form. All right, so this page just kind of tells you what I've been talking about this whole time. I'm not going to read it to you, so you might want to hit pause and take some notes over this page. One thing I do want to point out on this page is step 2, right here. Test a point that is not on the boundary line. Is it a solution of the inequality? Well, I've been showing you the is it above or below the line thing. That is really step 2. So you can do either what they say, test a point, or you can do is it shaded above or below, okay? They're the same thing. All right, and I'm going to show you in the next example how to test a point that is not on the boundary line, just so you know both ways. All right, so let's graph this thing. Okay, so same rules apply as if there was an equal to symbol there. So we would graph the line y is equal to 3/4 x minus 2. Okay, let's graph this. So I would go to -2 on my y-axis. From there, I'm going to go up 3, right 4. 2, 3, 1, 2, 3, 4. Or from that dot, I could go down 3, left 4. Okay, now I've got 3 dots on here. It is truly not a line until we connect the dots, okay? And so we need to decide if this is going to be a solid line or a dotted line. Because we are dealing with a greater than or equal to, this right here tells us that it has to be a solid line, okay? So I would draw a solid line. Now we have to decide where to shade. Now, remember whenever I told you that step 2 was to test a point? Well, I also taught you that if it's greater than, you're going to shade above, and if it's less than, you're going to shade below. Let me show you how to test a point. Now, I usually pick a point that, that makes my life easy, okay? And so I want to pick a point that whenever I substitute the values in, I know if it makes a true statement or a false statement. So here's what I'm going to do. I'm going to pick 0, 0. It is not on the line. You do not want to pick a point that is on the line. Okay, and I'm going to substitute it into my original inequality. Okay, so I'm going to put in 0 for x and 0 for y, and see if it makes a true statement. This goes away. So 0 is greater than or equal to -2. Is that a true statement or a false statement? It's a true statement, right? Okay, so since it's a true statement, we shade the region that holds 0, 0 in it. Okay, so we would shade this whole region right here. Everything above that line. Okay, so what about this problem? It's written in standard form. I don't know where my slope is. I don't know what my y-intercept is. I've got to figure that out. Okay, so let's do that. So I've got x minus 2y is less than 5. I would subtract x from both sides. Remember, I'm turning this into slope-intercept form. Don't forget, when you divide or multiply by a negative, you still have to flip the sign around, okay? Notice it went from a less than to a greater than here. And a negative divided by a negative is a positive. So I would have 1/2 x minus 5/2, which is 2.5, or minus 2.5. Okay, so now I'm going to graph this thing. All right, so I'm going to go to -2.5 on my y-axis. From this dot, I'm going to go up 1, right 2. Or I could go down 1, left 2. Now, I need to look to decide if I need a solid line or a dotted line, and because this does not have an equal to sign underneath it, I will have a dotted line. So dot, dot, oops, let's draw. Now I need to decide where to shade. Remember, if it's greater than, I shade above the line. If it's less than, I shade below the line. So that area would be my shaded region. All right, so what about this one? We don't have a y-intercept here. So I've got y is less than or equal to negative 4x. But I do know that my y-intercept is 0. Remember, plus 0? That doesn't change our inequality at all, does it? So our y-intercept is here at 0, 0. From here, I'm going to do my slope, which is down 4, right 1. 1, 2, 3, 4, right 1. Or up 4, left 1. Okay? Now, do I have a solid or a dotted line? I'm going to have a solid line this time because it's got the equal to symbol underneath. So, I don't have a ruler with me. I'm sorry about that. So, we'll pretend like this is a solid line. A straight line, I guess I should say. Now, we need to decide where to shade, okay? If I were to use that method where I test a point, it wouldn't be a good idea to use 0, 0 because my line goes through 0, 0. So I might want to try this point right here. It doesn't matter. It can be any point you want. It could be this point right here. It's still on one side of the line. So that's what I'm going to do. I'm going to test the point negative 1, 1. So we're testing negative 1, 1. So I'm going to put positive 1 in for y. I'm going to put in negative 1 for x. So 1 is less than or equal to 4. Is that a true statement? Yes. So we would shade the region that holds that point. If it was a false statement, in this case it's true, if it was a false statement, we would shade the opposite side. Okay, so what if you don't have an x in your inequality? That's all right. We can still graph this. So y is greater than 3. If it were y equals 3, how would it look? It would truly look like a horizontal line. Right there. That's y equals 3. But remember, I have to look to see if I need a solid or a dotted line. And in this case, I actually need a dotted line, don't I? So I'm going to erase a little bit. Come on. And I'll draw a little bit more. There we go. Now we have a dotted line. And think about this. Do I want to shade above or below? Where are your y's greater than 3? Well, are they greater above the line or below the line? I think it's intuitive to say that they're greater above the line. So let's shade up there. If you wanted to test a point, you could test a point. You could test 0, 0 at this point, okay? And what we would hope to get out if we tested 0, 0, we would hope to get out a false statement. So if I test 0, 0, check this out. 0 for y, I don't have to put the other 0 in anywhere because there's no x. Is 0 greater than 3? That's false. So you don't want the shaded region to be where 0, 0 is. We don't want the shaded region down here because this is a false statement. All right. I hope you found this video helpful.